Hi, my name is Oscar Alvarez. I'm from the University of Texas at Arlington, and I'm going to be explaining how to take the data, the Liutex data, and opening it up in Tecplot360 and showing you a comparison between the Liutex magnitude isosurface and the Liutex Omega isosurface. So what I have here is plot 3D data, and you can see that because we have a .fun file, the dot function file, and a .xyz file, which is the grid file. Another file that I have here is the variable names .nam file, which is a name file. Now the reason I have this file is it's the list of all the variable names in my function file. So if I already have it opened up here, but if I open up Tecplot, and this is the data that I have without loading the name file, if I look at my data, it just shows F1, V1, V3, V4, V5 for all my variables. You can enter the name manually, so I can go in here and double click and type in U and tab and then V, W, and so on and so forth, but I would have to memorize the name of all the variables, and every time I open Tecplot I would have to type them all in. So instead of doing that, I created the this .name file, and I put all the names of the variables in this file, and it's just the name of the variable, and you press enter, and then the name of the next variable, and so on in order. So you see that when I open all three of these files at the same time, and the way I'm going to open them is I'm going to highlight all of them at the same time, or I can just hold control and click all of them at the same time, and I'm going to drag it over the Tecplot icon here, and that will open all the files at the same time using Tecplot. And see, now I have Tecplot open, but this time when I look at my data, all of the variable names are filled out. I have all the variable names pre-filled out for me, which is exactly what I want. So now we're going to be looking at the data that we have. And now this is hurricane data, so I'm going to be adjusting some things here. We're going to be looking at the isosurfaces, so I'm going to just do some formatting. I'm showing all the axes so I can see the values. I want to stretch it vertically, the data vertically, so I'm setting the grid dependency to independent, and I want my Z to be longer. That should be just fine. Now that my Z is longer, I can now plot my isosurface. So let's compare some of these isosurfaces. Turn on my isosurface. And for the first group, I'm going to be looking at the Liutex magnitude. So these are the Liutex magnitude values. So let's find a favorable value that shows up a little bit more information. So this is hurricane data. If we add a slice here in between, so Z slice, and is the Z slice also pressure? No, magnitude. We can see the tornado data, and we could see a little bit more atmospheric friendly. You could see if we look at it from the top, we have the swirling of the hurricane. All right, so let's compare some isosurface values. So this is contour and shade. I want it to be Liutex magnitude. here is my Liutex magnitude ISO surface. I'm going to move this out. I'm going to just delete that. So this is my Liutex magnitude ISO surface. Now, the Liutex magnitude describes the strength of rotation. So this is not in any way related to the range of my data. This is just the absolute strength of rotation. So I can see that if I increase the strength, the ISO surface threshold, that I will find the stronger vortices. I will find stronger vortices. Let me change it to strong to different color. That if I increase the value, I will find stronger and stronger vortices, but the rest of the structures disappear. So let's say I want to include those weaker structures, and when I include the weaker structures, the stronger vortices that are lying within kind of disappear too, and it's kind of a mess. But all these are vortical structures, vortical isosurface structures using Liutex magnitude. But let's say I want to see the strong vortices and the weak vortices at the same time. Well, there's another method that was developed, and that's the modified Omega Liutex method, which the modified Omega Liutex method it normalizes your Liutex data. So it takes the values that you have for Liutex and kind of normalizes it between a value between 0 and 1. So let's look at Omega Liutex magnitude, and I'll just do just random color. Okay. So right now I'm showing both of them at the same time. So I only want to look at the Omega Liutex magnitude. So I'm going to turn off viewing group 1, which is Liutex magnitude. And if you're looking at a value between 0 and 1, 0.52 has been found to be a very good value for looking at both strong and weak vortices simultaneously. So I'm going to enter 0.52. And now this is my my modified Omega Liutex magnitude isosurface, where I can see in general where most of these vortices are, both strong and weak. Now if I take a look around, you could see in general these are where most of the vortical structures are. And I myself am not a hurricane analyst, but you can still see some of the swirling that's going on. And this is the difference between the modified Omega Liutex isosurface, is that in general the Omega Liutex will show you all of the weak and strong vortices at the same time, removing a lot of the clutter. As when we compare looking at just the Liutex magnitude, you kind of have to select. Here's some without a bunch of clutter, but if you look at, let's see if I can get them relatively close. Let's see. So you see how high or how weak your vortices have to be to include all of what Omega has to do. So if I remove Liutex Omega, it's very, very cluttered, and you cannot see very much of the vortices. So what I have to do, or what would be better, is to show the modified Omega, and you can still see how much of the artifacts or extra vortices have disappeared, and you can see the main vortex structure using a single ISO surface. So that's the benefit of using modified Omega Liutex over Liutex magnitude when you're looking at ISO surfaces. With modified Omega Liutex, you see weak and strong vortices at the same time.